All right, hello to whoever's listening to this video. This one is going to be on the first law of thermodynamics, which is probably one of the most important topics that you're going to learn in this class. And if you understand this one, the rest of the class is going to be quite easier. So, what the first law basically is the difference in energy is going to be the energy you put in minus the energy you put out. And it can be further simplified by the heat supplied minus the heat that is going out of the system, plus the work supplied minus the work produced by the system. So for a closed system, the change of the rate of mass is going to be zero since the system is closed. There's no mass going through the system and exiting the system. So this equation remains the same. However, if the system is open, we must also add the change of energy of the mass. So E dot mass, which is can be further simplified by not simplified by, but subdivided into E mass in minus E mass out, just as heat and work was. Um, so what is E dot mass? It's basically the rate of change of mass multiplied by the enthalpy plus the kinetic energy, which is V squared over 2, plus the potential energy, which is Gz. Yeah, so if you put it in the formula, it's going to basically give you this. Uh, so for further examples, we're going to show only two examples in this video, but you're going to learn much more in classes. So the first one is going to be nozzles and diffusers, which is probably the most basic device possible. It's just an opening through which a fluid flows, and either a smaller or a bigger opening at the end, which will allow either to increase or decrease pressure. Uh, in nozzles is going to decrease pressure but augment the speed, the velocity, and the diffuser are going to be the opposite of that. So in these devices, the difference of potential energy is often going to be equal to zero. So it's going to be Q dot and W dot, which is going to be the heat rate and work rate. They're both going to be zero. So if you put that into the equation, you can isolate, you can basically put one of the initial conditions on the one side and the final conditions on the other, which is going to simplify to this equation. And for another example, turbines and compressors, and they're going to either take work or put out work to either compress a air or a gas or something like that, or they're gonna use the compressed gas to basically put out work. So through these conditions, they're gonna have heat transfer equal to zero. Their potential energies and their kinetic energies are often gonna be zero too, unless specified otherwise. And more often than not, they're gonna be specified to be something else. Uh, yeah, so you can put that into the equation, and if you respect these three parameters, you're just gonna end up with this equation. However, I made a little mistake making this PowerPoint. Never mind the dot, since you're dividing by m dot on both sides when you isolate the w dot, and it's just going to be work equals to enthalpy initial minus enthalpy final. Yeah, so in conclusion, the the most important thing to remember is how to use this equation. So basically, they're going to give you the parameters of some of these of some. They're going to give you the values of some of these parameters. For example, enthalpies, velocity. Uh, Often potential energy is going to be equal to zero, so very often you're just going to ignore it. However, the most important thing for me, and also I know some other students that also mess this up in the beginning, they assume that these three parameters in compressors, turbines, and these three parameters in nozzles and diffusers are going to be equal to zero. However, it is important to remember that it's not always the case, and you cannot just assume it. So it's always easier to just write this equation down on the paper and then just go on from there.